In this video, I will discuss the ladder friction and numericals of friction. Uh, Suppose this is a wall and this is a floor. Now, if you keep a ladder like this, then what will happen? Let the ladder be AB. The ladder be AB of length L. Ladder of length L. Uh, Now and weight W. Let us say the angle the ladder is making with the floor be theta. Now Ra will be the reaction at point A and Rb will be the reaction at point B. Now if you keep the ladder like this, then the point A will have the tendency to move down. If point A will move down, then the point B will move in this direction. So if A moves down, then the frictional force will act upward, that is Fa, and if B moves outward, then the frictional force will act inward, let it be Fb. Now if you apply conditions of equilibrium, let us say sigma h is equal to 0, then what we'll get? We'll get Ra minus Fb equal to 0. So Ra is equal to Fb. If mu is the coefficient of friction between wall and ladder and between floor and ladder both, then it will be mu Rb. This you know, mu into R. F is always mu into R. Now if you apply sigma V equal to 0, then what we'll get? We'll get Fa plus Rb. This is equal to W. Now what is Fa then? Fa is mu into Ra. There is a frictional force at point A plus Rb equal to W. Now if I put the value of Ra from equation number 1, then what we'll get? We'll get mu Ra is mu into Ra is so if I put the value of Ra, what we'll get mu into mu Rb plus Rb equal to W. So finally we'll get mu square Rb plus Rb equal to W. Now Rb is equal to then 1 plus mu square equal to W. So Rb is W upon 1 plus mu square. So the reaction at B we can easily calculate. Now, if you put the value of RB in equation number 1, then RA will be equal to, RA will be mu times W upon 1 plus mu square. So, now from this we can easily find out FA and FB, these are the frictional forces at point A and B. FA is mu into RA. So, FA is mu into RA and we know the value of RA. So, this is mu into mu W upon 1 plus mu square. This is the value of friction at point A, and the value of friction at point B, that is FB, this is equal to mu into RB, and that is equal to mu into W upon 1 plus mu square, because the value of RB we got is W upon 1 plus mu square. So this way we can easily find out the frictions at point A and B of the ladder. Now the numericals. Now the first numerical is that what force would be necessary just to maintain equilibrium in a body weighing 914.5 Newton. Now along the horizontal plane, that means what force is required along the horizontal plane, and B at an inclination of let us say in an inclined plane having the inclination 1 in 10. The coefficient of friction given is 0.08. So the for condition A, so for the first case, what force should be necessary just to maintain equilibrium in a body weighing this? So there is a horizontal plane, and let us say this is the body having weight 914.5 Newton. Now what force would be necessary just to maintain equilibrium in a body along the horizontal plane? So let us say uh, force P is required to keep it in equilibrium. Now R will be the normal reaction, this you know. If P is acting in this direction, then F will be, frictional force will act in opposite direction, let it be F. So this is the frictional force. Now you apply conditions of equilibrium, summation of V equal to 0. So R is equal to 914.5 Newton. Then we'll apply sigma H is equal to 0, that is P equal to F. What is F? F is mu into R. What is mu? Mu is 0.08. What is R? R we have calculated 914.5. Now if you calculate, the value of P will be 73.16 Newton. So this is the answer of this 76.16 Newton. Now for case B, of an inclination of 1 in 10. So this is an inclined plane. So the body is kept on an inclined plane. Let this angle be theta. The body is, is kept here. Now let us say a force P is required to keep it in equilibrium. This is the normal line. W will act in this direction, and this is the normal reaction, you know. And if to hold it, keep it in equilibrium, so if P is acting upward, so obviously F will act downward. So F will act downward. Uh, this is the W, and if you resolve, you will get W sin theta in this direction and W cos theta in this direction. This will be W cos theta, and this will be your W sin theta. Now, what is tan theta then? Tan theta given to you is 1 upon 10. 1 in 10 का मतलब है tan theta is 1 upon 10, that is 0.1. So the value of theta you calculate from the calculator, you will get 14.04 degree. So you got the value of theta. Now again you apply, here you know the coordinate axis will be like this, parallel to the inclined plane this will be x, and perpendicular to the inclined plane this will be y. So applying conditions of equilibrium in the inclined plane, let us say first I am applying sigma v equal to 0, that is sigma fy equal to 0. What I am getting, r is equal to w cos theta, r equal to w cos theta, w cos theta. Now w is 914.5 cos 14.04 degree, and the value of r will be then, the value of r will be then value of r will be then 909.96 Newton. Now if you apply sigma h is equal to 0, then what you will get? You will get P equal to F plus W sin theta, that you can see from the figure. Now what is F? F is mu into R plus W sin theta. Now what is mu? Mu given to you is 0.08, 0.08, and we have calculated R as 909.96. Uh, this is actually W sin theta, not F. So this is W actually. Now this becomes then 914.5 sine 14.04 degree. If you calculate, you put the values using the calculator, and if you calculate, the value of P will be 163.79 Newton. 63.79 Newton. So this much force is required to keep the body in equilibrium. So this is the answer of example 1. Now, the next example is a body weighing 5,880 Newton is lying on a wooden plank with an inclination of 1 into. The coefficient of friction is 0.25. State if the body will rest on the plank or not. If the body moves down, what force parallel to the plank is necessary to hold it back? The body is again in an inclined plane. The inclination is given to you 1 in 2. So the body is in inclined plane. Having the weight 5,880 Newton. Now this is the normal line. This is the normal reaction R, and let lying a so a body weighing this much is lying on a wooden plank with an inclination of 1 into. The coefficient of friction is this. Now how can you decide whether the body will be at rest on the plank uh, due to its due to the friction only? Now ये हमने पहले ही बताया हुआ है कि अगर ये if the value of theta is equal to value of phi is the angle of friction. So if theta is equal to phi, that is angle of inclination equal to angle of friction, then the body will remain at rest. But if theta is greater than phi, then the body will move down. So for this we have to calculate theta and phi. Now tan theta. What is tan theta? So tan theta is 1 into, that is 1 upon 2, and that is equal to 0.5. So the value of theta is equal to 26.56 degree. Now we know tan phi is equal to mu, and the value of mu given to you is 0.25, coefficient of friction. So the value of phi, this is equal to 14.04 degree. Now here, as theta is greater than phi, so the body will slide down. The body will slide down. The body will slide down. So the body will slide down. Body will slide down. Now, if the body will slide down, then to keep the body in equilibrium, let a force P is required to keep the body in equilibrium. Now, because the body is sliding down, so automatically the frictional force will act upward. Now again, applying conditions of equilibrium. So applying conditions of equilibrium on the inclined plane. So first I am applying sigma v equal to 0. If we apply sigma v, then what we are getting? We are getting R. This is equal to W cos theta. W is 5,880, and the value of theta is 26. So cos 26.56 degree. Now if you calculate, the value of R will be The value of R will be 5259.6. 5259.46 Newton. Now if you apply sigma H is equal to 0, we are getting P plus F, that is equal to W sine theta from the figure. Now P is equal to then W sine theta minus F. Here W is 5880 sine 26.56 degree, and F is mu into R, we know. So mu is 0.25. Yes, mu is 0.25, and R we got is 5259.46. Now if you calculate this, you get the value of P as 1314.29 Newton. So 1314.29 Newton. This is the answer. This is the answer. Now the third example. A pull of 60 Newton is inclined at 25 degree to the horizontal plane is required just to move the body placed on a rough horizontal plane. But a push rough horizontal plane. So a pull of 60 Newton is inclined at 25 degree to the horizontal plane is required just to move the body placed on a rough horizontal plane. So there is a rough horizontal plane. So there is a body which is kept on a rough horizontal plane. Now pull of a pull of 60 Newton. So this is the pull of 60 Newton. So 60 Newton force से हम खींचेंगे, inclined at an angle of 25 degree. This angle, this is given to you 25 degree. This angle is 25 degree given to you. Now placed on a rough horizontal plane. So if it is moving in this direction, so the frictional force will act in opposite direction. So let it be F. So this frictional force be F, let us say. Now this, let the weight of the body be W, and the reaction is R. So this is the first case. Now second case I am reading. Now, but the push required to move the body is 75 Newton. If the push is inclined at 25 degree to the horizontal, find the weight of the body and the coefficient of friction. So the figure of the second case is this. So this is the body kept on the horizontal plane. This is the weight of the body W, and this is the uh, reaction R1, let us say here, because this is the second case. Now if you are applying a push, so push, अगर इसे हम इस तरह से push करें, so push is applied again at an angle of 25 degree. Push of 75 Newton is applied at an angle of 25 degree. Then you have to find out the weight and the coefficient of friction mu, let us say. Now if you are pushing, so the body will move in this direction, so the frictional force will be in opposite direction. Let the frictional force be F1. So the case 1, or case 1, if you apply conditions of equilibrium, what we will get? Let us say I am applying sigma v equal to 0 for in first figure. What I am getting? I am getting r plus 60 sine 25 degree. This is equal to w. This is equal to w. So r is equal to then. So r plus 6 r plus, now if you calculate, we'll get 25.36. So r plus 25.36, this is equal to w. Mind it, w and mu are unknowns. Mu is the coefficient of friction here. So this is equation number 1, let us say. Now if you apply sigma h is equal to 0 in figure 1, this is the figure 1, and let us say this is the figure 2. So applying sigma h, what I'm getting, we are getting 60 cos 25 degree. This is equal to f. What is f? F is mu into r. So 60 cos 25, if you calculate the value of 60 cos 25 is 54.36, and that is equal to mu into r, and therefore r is equal to 54.36 on mu. Now if you put the value of r in equation number 1, so putting r in 1, we get, putting the value of r in 1 rather. So what we are getting? We are getting 54.36 upon mu plus 25.36. This is equal to w. Let us say this is equation number 2. So this is for first case. Now in the for second case, for for the second case, uh, again I will apply, for the second case I will apply again so case 2. So for second case, uh, again we'll apply conditions of equilibrium. Let us say sigma v equal to 0. If you apply sigma v equal to 0, what we'll get? We'll get r1 equal to r1 uh, r1 will get r1 equal to w plus 25 sine 25 degree. So w plus 75, that is a push we are applying. So the component of push in the vertical direction is this sine 25 degree. So W plus 75 sine 25 degree. Now R equal to W plus 31.69. If you calculate this, will get 31.69. Let us say this is equation number 3. Now we'll apply sigma h is equal to 0 in second equation. In second figure, we'll get we'll get uh, we'll get f1. This is equal to 75 cos 25 degree. There is some error in uh, in figure 4.26 second part. If the direction of f1 will be opposite. So f1 cos 25 degree. Now what is f1? F1 is mu into r1 and mu into r1 and 75 cos 25 is 67.97. So the r1 is equal to 67.97 upon mu. Now we'll put the value of r1 in equation number 3. So putting r1 in 3, we get what we get. We'll get uh, uh, we'll get 67.97 upon mu. This is equal to W plus 31.69. This is 31.69. Now we have already calculated W in equation 2. So we'll put the value of W from 2 into this equation. So what we'll get? 67.97 upon mu. This is equal to mm, this is equal to 54.36 upon mu plus 25.36. So this entire is the value of W plus 31.69. So what I did, I put the value of W from equation number 2 in this equation. So finally I'm getting this. Now if you calculate, if you simplify, what you will get 67.97 upon mu minus 54.36 mu, and this is equal to, if you add these two, you will get 57.05. Now finally if you subtract these two, will get 13.61 upon mu, and this is equal to 57.05. So the value of mu will be is equal to 0.238. So this is the value of mu. This is the answer. Now you have to calculate W also. Now you put the value of mu in equation 2. In equation 2. So putting the value of mu in equation 2, what we'll get? We'll get W is equal to 54.36. Now the value of mu already got is 0.238 plus 25.36. Now if you calculate, we'll get the value of W as 253.76 Newton. So this is the answer. So you got the value of mu, you got the value of W. So this way you can solve this numericals. Now you try other numericals. If you have any problem, we'll discuss. So this is the end of this video. Thank you very much.